Going on now to topic 8 of chapter 3. This is one that I hadn't included before, but we'll do it. And it's something I'm familiar with, and you should have some background from this as well. This ties in business and economic applications. We're talking about a break-even analysis and supply and demand. Now, to give you a little background on this, we might look at this situation. I'm going to make a little graph here for you. This is quadrant 1. And let's suppose it costs a certain amount of money to start up what you're going to sell. And on a amount line, which is your y-axis, you end up with a curve like so, or a straight line like so. And then you're going to sell a product. And for every product you sell, there's a certain charge. And that line looks like so. So what do you notice then about this point right here? Yes, the lines intersect. So anything, once it crosses the blue line, any point above here indicates profit. So this is what it costs to make the item you're selling. This is the selling price. And this is going to be the cost function. And the red line is going to be the revenue function. And we're looking to see where they intersect. Okay, that's some background of what we're going to be doing. So when a company manufactures X units of a product, it spends money. This might be equipment, it might be the renting of a facility, the electricity, the wages of the workers involved. So this is total cost and can be thought of as a function C for cost, where C of X is the total cost of producing X units. When a company sells X units of the product, it takes in money. Capitalism here. This is considered revenue, and the total amount of money you bring in is total revenue. And for this, we use the letter R for revenue, where R of X is the total revenue from the sale of this many units. Okay. So continuing and keeping in mind the graph we had on the first slide, total profit is the money taken in less the money spent. So again, if we make that graph, and you'll see some as we come up here, above the blue line, that is profit. Okay. So if you have profit is equal to revenue minus the cost, or the profit is equal to the function of R minus the function of C. And that's what we just talked about. And there are two types of cost. Costs which must be paid whether a product is produced or not are called fixed cost. Costs that may vary according to the amount being produced are called variable cost. So fixed costs would be things like the equipment, the building, and variable costs would be things like the material physically used in the making of something. As you produce one product, then you need more material to make another product. But you'll be using your machines, you'll be using the building you're in, and this type of thing. Now the sum of the fixed and variable costs give you total costs. So this is like a little mini economics course here. So a specialty wallet company has fixed costs that are $2,400. Each wallet will cost $2 to produce. And so there's fixed costs, variable cost, and there's your revenue. The sales price is $10. So they give us a series of questions here. Well, before you see the slides, let's see if we can make up some equations here. So our cost of X will be, when we go to make one, we have to spend $2 for each item. This is the number of items we're going to make. And this is our variable cost. And then the fixed cost are $2,400. Okay, we are now doing our revenue. And that's kind of an easy one. Now, when we sell a particular item, we make, well, we don't make, but that's what we take in, $10 for each item sold. So here basically are our two equations. Now, notice the way they're set up. They're sort of in the form of y equals mx plus b, where b is your y-intercept. That's your fixed cost on this axis. Let's see if I can do it here quickly. That would be right there. And then your sales would be like so. And again, where they intersect, that is your break-even point, where you're taking in enough money to cover your cost. Above this point are your profits. Okay? So let's take a look. So we did that, and we did this. So we need to find the total profit from the production of sale of X wallets. What profit will the company realize from the production and sale of 500? So here we're going to put 500 there and 500 there. And then graph the total cost and total revenue and total profit functions determine the break-even point. Well, we gave you a little hint of what's going on here, and the text actually, the slides do a good job in showing you this. So let's go ahead. So fixing our cost, fixed costs plus variable. I had put this first because that would be more in the slope-intercept form. And revenue, that's straightforward. For each wallet X, you get or receive $10. Now, total profit then will be P of X, that's total profit, is equal to revenue minus cost. And these are the two parts of the formulas that we had. So if we put 500 in there, we will realize a profit of $1,600. When I was a young fellow, I worked as in my senior year in high school. We had a junior achievement company where basically it was to meet with adult supervisors that help us develop a corporation. We would develop a product, buy the raw materials. Well, we would sell stock in the company, buy the raw materials, manufacture the product, and then sell it. And then any money over our cost was profit that we gave to our shareholders. And we could buy stocks ourselves. And the year I was the president of the company, why, we did pretty good. We made a hand cream, and it's interesting in seeing how hand cream is made and putting it in bottles and labels and selling. And it was a very good hand cream too, because we had a chemist as our advisor, so they knew exactly what was going on. Okay, so that's enough background here. Let's go back one slide here. So on our next slide, we'll see the graph of the interaction of revenue, cost, and profits. So there we go. Now notice we are in quadrant 1 of our graph, where this is amount of dollars, and that's our y-axis, and our x-axis is cost, or I should say number of items sold. So again, we didn't sell any. We're looking for that point of intersection. Okay, so above this line, this is profit. If we don't sell this many units, we will be at a loss. Okay? So here's a summary. Gains occur where the revenue is greater than the costs. Losses occur when the revenue is less than the cost. And the break-even point occurs where the graph of R and C cross their intersection. Thus, to find the break-even point, we solve this system. Now, notice something here. We can put a y here and a y there. This function notation we can substitute with the letter y. So here we have, in a sense, y equals y. So our equation will be 10x equals 2x plus 2400. So we subtract 2x from both sides and get 8x equals 2400. And now we divide both sides by 8, and we get x equals 300. Now, what's the significance of this answer? Well, the significance is that we have to sell 300 units to break even. And we did so by equating our revenue equal to our cost. This is revenue equals the cost. Y equals Y. Again, this is something from earlier sections. Now, as we look at supply and demand, as the price of a product varies, the amount sold will vary as well. Consumers will demand less as the price goes up. So if something's very expensive, you're not going to sell too much of it. But if it's a good product and the price is lower, you're going to sell more. So this is supply and demand. Okay? So here we're looking for what is called an equilibrium point. So the red line indicates demand, the blue line indicates supply, and we're looking for an equilibrium point. That is, at that price, the amount that the seller will supply is the same amount that the consumers will buy. Think Walmart's. All right, little joke there. And they do give us some equations to indicate demand. Okay, that's the D. And the supply. Now notice here, this is negative slope. So this will be going down. And this is positive slope. But it's still, think of it as y is equal to y. So it's this going to be equal to that. So here they're using substitution. I would just solve it directly. So thus the equilibrium quantity is 144 units, and the equilibrium price is $32. And again, there's lots more that's gone into this than they're showing us. This is just a little introduction to supply and demand. One equation will be with negative slope, one equation with positive slope, and you're seeing where they intersect. And then getting your X and Y coordinates out of that. Okay, I'm going to also do the additional exercises in a different video, so you'll have those as references as well.